let us start our problems in project crashing. Okay, so I will start with some simple examples, then we will go for some bigger examples. Okay, so the first example is they given the activity, they given duration, they given cost slope. Cost slope is they given in terms of rupees per day. Okay, and they also given you the network diagram also. Okay, so in general they won't give the network diagram, you have to draw. In this question they given the network diagram, and the question is number of critical paths. So how many critical paths are there? The second question is what is the minimum amount to be spent to reduce the project duration by 1 day. So for reducing 1 day, how much minimum amount I'm going to spend? Okay, so if I want to crash 1 day, how much is the minimum amount I'm going to spend? That's what they're asking. So to start with, first let us find out the critical paths. Okay, so what are the different paths which is available first? So A, E, F is one path. This is a dummy. Okay, this is a dummy. 2 to 3 is a dummy. So A, E, F, that is one path. A, E, F, and the next one will be A dummy D, F, right? So A dummy DF. Okay, I'm sorry, DF. And the next one is BDF. Okay, BDF. Next one is C and F. Okay, next one is C and F. So now we need to find out the duration. Very simple, right? So it's going to be 17 and it's going to be 23. So AEF is 23 and A dummy DF 8. Again it is 17 and again it is 23. Right? So there is no change here. And the BDF is going to be 15. It's going to be 21 and CF 16 plus 6, which is going to be 22. So now what is the longest path here? The longest path is AEF and A dummy DF. So these two are the longest path, and obviously these two are the critical path. So how many critical paths are there? 2 critical paths are there. And what are the critical paths? A, E, F, and the another path was A dummy D. Okay, A dummy DF again. Okay, so these are the 2 critical paths which is available. Okay, so we got the first answer. What about the second answer? Minimum amount to be spent. How much I need to spend to reduce the project duration by 1 day. So here the project duration is 23. Okay, so I need to reduce it by 1 day. Let me first write down it separately. Okay, our critical paths are A, E, F. A dummy D, F. Okay, so the duration, the project duration was 23 days, 23 days, right? So project duration of if I am calculating by this path or this path, my duration is 23 days. Now what is our requirement? We need to reduce it by 1 day. I need to decrease it by 1 day. So what are all the different options which is available? If I want to crash it by 1 day, what are all the different options available and what are the corresponding cost slope? Rupees per day, right? Rupees per day. Right. So what are the different options? Ultimately our aim is what? To reduce this from 23 to 22. To reduce this from 23 to 22. Okay. So what are the different options available? See, if I crash activity A, okay, if I crash activity A, then activity A is present in both the critical paths, right? Activity A is present in both the critical paths. So if I crash activity A just by 1 day, simply if I reduce this 8 to 7, okay, if I reduce this 8 to 7, what will happen? The duration of AEF is going to be 22 and duration of A dummy DF is going to be 22, that is 1 day is going to decrease. So only by crashing, that is only by reducing 1 day of activity A. Okay, so that is first option which is available for me. Okay, so crashing only A. Okay, by crashing only A, we can reduce the duration by 1 day. And what is going to be my cost slope? If I am crashing A by 1 day, the cost slope, that is the cost is going to be 80. Okay, so it's going to be rupees 80 per day. Okay, now what about the next option? F F is also common, right? If I crash F by 1 day, okay, simply, if this 6 is reduced to 5, now I'm not crashing A, okay, I'm checking all different options, different possibilities. This is one possibility. The second possibility was what? I'm not changing the A duration. I'm going to change only F duration. I'm going to decrease the F duration from 6 to 5. I'm going to crash the F duration from 6 to 5. Okay, so I'm going to crash it by 1 day. And if I crash F, then automatically both the paths will get crashed, right? So the project duration along this path will also get decreased. Project duration along this path will also get decreased. So the second option which is available is crashing only F. Okay, so what about the cost slope? F cost slope was 130. Okay, rupees 130 per day. Okay, so if I am going to crash F, then it's going to cost me 130 rupees. Now what are the other possibility? So you cannot do anything with respect to dummy because dummy doesn't have any resources, doesn't consume any resources. Other two options which is available to me, what I can do. What if I crash E? Okay, if I crash E by 1 day, listen carefully. I'm not touching A, I'm not touching F. This is the third option. This is the third option which is available for me. If I crash E by 1 day, what will happen? So I'm crashing it from 9, okay, I'm decreasing it to 8. If I crash it from 9 to 8, what will happen? 8 plus 8, 16, 16 plus 6 is going to be 22. So this path has decreased, duration has been decreased. But what will happen to this path? Both are critical path, right? The project completion time will be decided by critical path only. Now, by crashing only E, okay, by crashing only E, this path duration is decreased to 22, not an issue. But still, project completion time is 23 days. Why? Once this path duration reduced to 22, this won't be my critical path because this path will have duration 23 still it is having duration 23. So if I want my project duration to be reduced, I need to crash both. By 1 day. By crashing only activity E, only this path has been decreased. Okay, that is the duration of the path. Sorry, duration of the path of this. Okay, duration of this path only decreased by 1 day. Without crashing any activities here, I cannot do anything. That is, without crashing any activity here, its duration will be still 23. So what I can do, I can crash E by 1 day. Similarly, I can crash D by 1 day. That is, both has to be done simultaneously. Crashing E by 1 day and crashing D by 1 day. So that is our third option. Okay, so I need to crash both. Okay, both E and what is that? Both E and, let me write it here, both E and D. Okay, both E and D. So E should be crashed by 1 day, D should be crashed by 1 day. So now check what will happen. E is crashed by 1 day, so 9 becomes 8, and D is crashed by 1 day, so 9 becomes 8. So now check A, E, F. Summation is going to be 22. B, D, F. Summation is going to be 22. So what happened to project duration? Decreased by 1 day. So these are the three possibilities. One is if I crash A alone. Okay, if I crash A alone, since A is present common in both the critical paths, so if I am crashing only A by 1 day, that is enough because this path also reduced, this path's duration will also be reduced. So finally, the total project completion time is also reduced. By crashing only F, again F is present commonly, so this path duration is also reduced, this path duration is also reduced, no issues at all. But if I crash only E, only the first path duration will be reduced, second path will be still having duration of 23. That is not what we want, right? So the D duration should also be reduced by 1 day. So overall, what is the third one duration? E is taking 20, D is taking 40. So 20 plus 40, right? 20 plus 40, that's going to be 60 per day. Now, they are asking minimum amount to be spent to reduce the duration by 1 day. So which one I need to choose out of these three options? These are the available three options, and I will choose option 3. Okay, I will choose option 3. Why? Because out of three options, okay, we have three options for decreasing the project completion time by 1 day, but they are asking minimum amount. I need to spend minimum cost for crashing it, for reducing the duration by 1 day. So out of the 3 options, option 3, okay, that is by crashing both E and D, the cost was just 60 rupees. But if I crash A, it's taking 80 rupees. If I crash F, it is taking 130 rupees. So automatically, the third option is the preferable one, and that will give me the minimum amount, okay, the minimum amount to be spent to crash or to reduce the project duration by 1 day. So the correct answer was rupees 60. Okay, so let us continue for the next question. Okay, so in project crashing, so this is again a simple question but a bit lengthier. Okay, and by using this question you will understand the complete project crashing. Okay, so to start with, they given activity, they given normal duration, they given crash duration, they given normal cost and also crash cost. And the question is, they are asking what is the optimum duration. Okay, we already know, right, what is mean by optimum duration, the duration at which the total cost is minimum. Okay, that is what optimum duration. So I need to find out that. They given indirect cost per day. So as usual, to start crashing, start by finding out cost slope. See, here cost time slope is not given, they just given the duration and cost separately. So for finding out that, let me write it down here. Okay, activity and also the cost time slope. Okay, so first for 1 to 2 activity, what's going to be the cost slope? Just the difference between the crash cost and normal cost by the difference between the crash duration and the normal duration. So difference between this two is 6,000 and 6,000 by difference between this two is 3. So 6,000 by 3 is going to be 2,000. So rupees 2,000. Actually the unit will be rupees per day, right? Cost slope unit is, okay, right. Let us consider the durations are given in terms of days. Okay, the durations are given in terms of days. Okay, what about 1 to 3? 1 to 3, again the difference between these two is 4,000 and by 2 it's going to be 2,000. Okay. Okay, what about 2 to 3? Difference between the cost 3,000 by 3, which is 1,000. Okay, and again for 2 to 4, difference between this two is 8,000 by 2, which is 4,000. Okay, so 2 to 4 is rupees 4,000. Okay, and finally 3 to 4, difference between this two is 5,000 by 2, which is 2,500. Okay. So overall, we determined that the cost slope corresponding to the activity, right? Next step is draw the network diagram. In the previous example which we seen, network diagram is already given in the question. Here they didn't given, but we can find out very easily because it's very simple. They already stated the activity, right? First is 1 to 2. Okay, 1 to 2 is an activity. Let this be an activity 1 to 2. 1 to 3, okay, another activity 1 to 3. 2 to 3, so from 2 again there should be one thing 2 to 3, right? So 1 to 2, 1 to 3 and 2 to 3, then 2 to 4, okay, there should be something like this 2 to 4 and again 3 to 4, okay, from 3 we need to go for 4, okay. So this is our simple diagram. And what about the duration of activity? For writing the duration, you need to take the normal duration. You should not take the crash duration. Don't forget that. Okay. So normal duration, it's going to be 1 to 2 is 6, 1 to 3 is 8, 2 to 3 is 4, 2 to 4 is 5, 3 to 4 is 5. Right. So we draw the network diagram. We found out the cost slope. So 2 steps are done. The third step is find out the critical path. Okay, so what are the different paths available? 1, 2, 4 is one path, 1, 2, 3, 4 is another path, and 1, 3, 4 is another path. Okay, so totally 3 paths are there. Okay, what about the duration? 1, 2, 4 is going to be simply 11. 1, 2, 3, 4, it is 15. Okay, 1, 3, 4, it is 13. Okay, so what is my critical path? 1, 2, 3, 4 is my critical path. Now from now, okay, until this, very simple, I am finding the cost slope, draw the network diagram, I determine the critical path. Now our aim is what? They are not asking us to find out what is the minimum amount for crashing 1 day, or find out what is the minimum amount for crashing 2 days. They are not asking like that. In this question, the clear-cut idea is they are asking the optimum duration. So for finding out optimum duration, what you need to do is, from this step, okay, simply find out what is the maximum possible crashing. Okay, maximum possible crashing in the network. I will explain what does it mean by that. Maximum possible crashing in the network. Just be patient and listen to me, okay, because from now the steps, it's very easy step, but you need to understand it, okay. So maximum possible crashing means what? Listen, crashing is done for optimizing the for reducing the project duration by optimizing the cost, right? The total cost has to be optimized, and I need to find out what is the optimum duration. So the cost has to be reduced, and corresponding to that, what is the duration? That's what I need to find out, right? So how to find out the minimum cost corresponding to what is that? Corresponding to optimum duration. Okay. So for finding out that, simple. If I change this, okay, this is our critical path. If I change this, if I able to reduce from 15 to 14, project duration is also reduced from 15 to 14. If I reduce it from 15 to 13, project duration is reduced from 15 to 13. So now the new project duration will be 13. Listen carefully. If I reduce it from 15 to 12, listen carefully. If I reduce this duration, okay, duration of this path from 15 to 12, what will happen? What will be my project duration? My project duration will be 13. You might get confused. Nothing is there to confuse. Very simple. Listen. If I reduce this duration from 15 to 12, obviously this path is not going to be my critical path. Reason? This path has more duration, right? This path duration is more. This is the longest path. This is the longest. Initially, this is the longest path. This is the second longest path. But if I crash it, if I reduce the duration from 15 to 12, if I reduce the duration from 15 to 12, then this will become my critical path. So reducing from 15 to 12 has no meaning here, because if I reduce it also, project duration will be still 13. I hope you are understanding. So what is the maximum possible crashing now? Simple, the difference between longest path and the next longest path. Okay, 15 minus 13, that is 2 days. So maximum as of now, okay, as of now, in this network, I can crash only 2 days. I can reduce this 15 to 13. If I reduce from 15 to 13, this path and this path, both this path will be my critical path. If I want to reduce the duration further, I need to reduce for both the path. Okay, until reducing this 15 to 13, I can worry only about this path. There is no issues at all. I can worry only about this path. I can concentrate only on that path. I will reduce 2 days only on that path. But once we reach 13, okay, once we reach 13, both of them will be critical paths. So I need to concentrate on both the paths. That is the basic concept here. So the maximum possible crashing as of now, okay, as of now in this network is 2 days only. Okay. So if I crash this 2 days, on which activity I need to crash? That also I need to see, because here 1 to 2, 2 to 3 and 3 to 4, there are 3 activities, right? So out of these 3 activities, which activity I need to crash? That is decided by using cost law. First, let us check out the options. Okay, what are the critical activities which is available? What are all the critical activities? That is corresponding options, okay? What are all the options available? And what is the cost law? Let us check it out. Okay, so first of all, the first option which I am having is 1 to 2. The second is 2 to 3, and the third is 3 to 4. 1 to 2, what is the cost law? 1 to 2 cost law is rupees 2000. Okay, rupees 2000. 2 to 3 is rupees 1000. Okay, well and good. And 3 to 4, rupees 2500. Okay, now say which one I need to crash. Which one I need to crash? Simply this. Okay, so I am going to crash this 2 to 3. I'm going to crash this 2 to 3 only. But now I need to check what is the maximum possible crashing which is available in the activity. Okay, let me check that also. See, we identified that this is the minimum cost, okay, minimum cost loop, that is identified, but we need to find out how much I can crash in 2 to 3. What does it mean? I will say, just wait for a moment. What is the maximum possible crashing in activity? Activity name is 2 to 3, right? 2 to 3. Okay, listen. The present duration of activity 2 to 3 is 4 days. Okay, it's 4 days. Now, what is the maximum possible reduction now I could do? See, there is an activity, I can complete the activity in 4 days. How many days I can reduce it? Maximum, I'm asking about maximum. How many days maximum I can reduce it? I can reduce it to only 1 day, right? I cannot do it in 0 days. I cannot complete an activity without time. I need time resource for completing it. So maximum reduction is from 4 to 1 only, right? From 4 I can reduce it to 1 only. Presently 4 days is available. Maximum I can reduce it to 1 day only. So the maximum reduction possible is 3 days. So I can reduce 3 days in 2 to 3. But what is my requirement? My requirement is 2 days only. My requirement now, I need to reduce the path, okay, reduce the path's duration by 2 days only, and this 2 to 3 activity is offering me 3 days, maximum it is offering me 3 days, but I don't need 3 days at all, right? I need just 2 days. So obviously I can crash this network 2 to 3 by 2 days. But if suppose, let us consider, just for an example I am stating, let us consider this is 2. Okay, let us consider this is 2. If it is 2, what will happen? 2 minus 1. Okay, so then this is going to become 1 day, right? So my requirement is 2 days. I need to crash 2 days in this path, but availability was only 1 day. So obviously I need to crash 1 day. This will be crashed by 1 day. And I need to choose the next one. Okay, next one is what? Next minimum cost loop. After 1000, 2000 only available, right? So 1 day I will crash 2 to 3. Another 1 day I will crash 1 to 2. Very important point. Okay. First we need to find out what is the maximum possible crashing in the network. Then we need to check out how much crashing possibility. Okay, that is very important. This is possibility. What is the maximum possibility in crashing the activity? Okay, so this activity 2 to 3. Now the present day was 4 day, so 4 minus 1, it becomes 3. So 3 day possibility is there. I can crash this activity 2 to 3 by 3 days. You can crash, but my requirement is 2 day only, so obviously I will crash it. So finally what I am going to do is, let me write it down. Let me write down here. So I am crashing 2 to 3 by 2 days. Okay, so this is our first crashing. Okay, first crashing is I am going to crash 2 to 3 by 2 days. If I crash 2 to 3 by 2 days, this 4 will become 2. Now I will be having a new critical path. But before going to that, we need to check whether our crashing is economical or not. If our crashing is not economical, I should not crash it. How to check whether my crashing is economical or not? Simple. They given indirect cost, right, per day. And what is our cost loop? Rupees 1000 per day. Okay, so let me write it down. Crashing cost per day is rupees 1000 and indirect cost per day is rupees 2000. And can I crash it? Is it economical? Is it economical? When it will be economical? If my crashing cost per day is less than indirect cost per day, it is economical. Here crashing cost per day is 1000, indirect cost per day is 2000, so it is economical, not at all an issue. So it is economical, so obviously I can crash this 2 to 3 by 2 days. Okay, after crashing, I need to draw the modified network diagram. Okay, so but make sure that your crashing is economical. If your crashing is not economical, you should not crash it. Okay, so very simple. once after drawing the network diagram and finding out the critical path, find out what is the maximum possible crashing. Okay, it's simply longest path minus next longest path. Okay, longest path minus next longest path. After finding out that, find out the cost lobes, that is, find out what are the different options available, okay, for crashing, and from that find out what is the minimum cost lobe, and from that minimum cost lobe you find out, okay, what is the maximum possible crashing. Okay, here 2 to 3, presently 4 days is there, so from 4 maximum I can reduce it to 1. Okay, from 4 days I can reduce it to 1, so 4 minus 1, we have 3 days. 3 days possibility is there. My requirement is 2 days only, not at all an issue. Happily I will crash 2 days. I can crash 3 days, but my requirement is 2 only, so happily 2 to 3 can be crashed by 2 days. Okay, so but before crashing, check whether it is economical or not. If it is economical, crash it and draw the new modified network diagram. Let us do now. So now after crashing the activity, okay, after crashing 2 to 3, it's crashed from 4 to 2. Okay, now 1 2 3 4 is also 13, 1 3 4 also 13, so there are two critical parts now, right? So 1 2 3 4 and 1 3 4. Okay, so both are critical paths, so both are having total duration of 13, 6 8 13, 8 and 5, it's going to be 13, so both are having duration 13, right? So first of all, what is the total crashing possibility now? I can reduce it from 13 to 11 only. Okay, 13 is the longest path, the next longest path is 11, so 13 minus 11, that is going to become 2. Okay, so that is the crashing possibility as of now. Let us check out the different options which is available for us. Okay, so what are the different options which is available for us? The options are, is there any common? Of course, yes, one common activity is there, right? 3 4. Okay, 3 4 is common activity. So if I crash only 3 4, okay, that is enough, right? Cost slope, that is one option. Okay, one option available. Because if I am crashing 3 4, obviously this 3 4 will also get crashed, that is both the path will get crashed. Okay, so what is the another option which is available? Another option is 3 4 has been done, right, because they are common. Other than 3 4 we have 1 2 2 3, right? So 1 to 2 and combined with 1 to 2 combined with 1 to 3. Okay, I have to crash both 1 2 and 1 3. Another option is 2 3. Okay, another option is 2 3 and 1 3, right? 2 3 and 1 3. So it's going to be 2 3 and 1 3. Okay, so if I am crashing only 3 to 4, because 3 to 4 is present in both, so if I crash 3 to 4, this will also get reduced, this will also get reduced, not at all an issue. But if I crash only 1 to 2, okay, if I crash only 1 to 2, that is not enough, because if I crash only 1 to 2, only this path will get reduced, this path will still remain same only, that is, that path duration will be still 13 only. So 1 to 2 and 1 to 3, okay, both 1 to 2 and 1 to 3. The next possibility is 2 to 3, okay, if I crash 2 to 3, this will get reduced, so 2 to 3 and 1 to 3, okay, 2 to 3 and 1 to 3, these are the other two possibilities. So if I substitute it here, okay, what will happen? First, crashing 3 to 4, how much is the cost slope? I already written the cost slope there. 3 to 4 means cost slope is rupees 2500, okay, 1 to 2 is 2000 plus 1 to 3, it's again 2000, which implies 4000, okay, and 2 to 3 is 1000 and 1 to 3 is 2000, which is 3000. So what is the minimum cost slope? Minimum cost slope is crashing 3 to 4. So best crashing option is 3 4. Okay, best crashing option is 3 4, but is this crashing economical? The crashing cost, okay, per day is rupees 2500. And what is indirect cost per day? If you remember, indirect cost per day, rupees 2000. So crashing cost per day is greater than indirect cost per day, so it is not economical. So crashing is not economical, so stop crashing, don't crash after 13. Okay, so 13 is the optimum duration. If I crash it from 13 to 11, okay, if I'm crashing 3 to 4, okay, if I'm crashing this activity, then our crashing will become non-economical. Okay, so you have to stop the crashing. So you have to stop the crashing, and further you should not do. Okay, so this one, okay, that is 13 is going to be our project duration. Further crashing from 13 to 11 should not happen. If it happens, then it's going to be non-economical. Why? Because crashing cost per day is greater than indirect cost per day. Okay, so now we found out the optimum duration. Optimum duration is TO, okay, which is going to be 13. Optimum duration is 13. Now what is going to be the total cost? Okay, without crashing, how much is the total cost? And now with crashing, after crashing, how many days I crashed? I crashed 2 days, right? From initially it was 15, from 15 I reduced to 13. How I did it? I crashed 2 to 3. Now in the second step, I tried to crash 3 to 4, but crashing cost per day of 3 to 4 is greater than that of indirect cost per day. So obviously crashing is not economical, so I should stop here. Okay, so I have to stop here itself. So our project duration is 13 after crashing, okay, after crashing 2 to 3. So this project duration, this optimum duration, by using this optimum duration, you need to find out what is the total cost, and without crashing, how much is the total cost. Find out and compare it. You will understand, or you will get to know about few points from that. Okay, so finally we got optimum duration, right? So optimum duration is 13. Initially the time duration was 15. From 15 it is reduced to 13. Now the optimum duration was 13. Initially, without crashing, the project duration seems to be 15, and indirect cost per day is 2000. So 2000 into 15 will give me total indirect cost. Similarly, normal cost, I need to add all the normal costs. Okay, so this will be giving me, the sum of normal cost will give me direct cost, and this will give me indirect cost. Okay. Now, if I add all these things with this, I will be getting 59,000. I'm not doing the calculation now, I already did it. Similarly, total project cost with crashing. Okay, so how many days I crashed? I crashed only 2 days, right? From 15 to 13 only I crashed. I tried to crash from 13 to 11, but when I tried to crash from 13 to 11, it became non-economical. So I stopped crashing at 13 itself. After 13, I didn't crash. So my optimum duration was 13 into 2000 will give me total indirect cost. So indirect cost has obviously decreased, right? Initially it is 2000 into 15. Now it is 2000 into 13. So indirect cost has decreased. Why? Because of crashing. But what happens to direct cost? You could see that this is sum of normal cost, that is not changing. Okay, 6000, 4000, 6000, 8000, 5000. Sum of normal cost is not changing. But crashing cost is getting added, right? So for crashing 1 day, I need 1000 rupees. Okay, for crashing that activity for 1 day, I need 1000. If I multiply with 2, because I am crashing it for 2 days, I already did that, right? So I crashed for 2 days, so 1000 into 2 will give me total crashing cost for crashing that activity by 2 days. So this combinedly, okay, this combinedly gives me the direct cost, and this gives me indirect cost. So indirect cost has decreased, direct cost has increased. Why it is increasing? Because of this 2000, right? 1000 into 2, 2000. So overall what is happening? See, overall the project cost was 57,000. Initially it is 59,000. So the total cost with crashing, okay, total cost with crashing is reduced, right? So this is one advantage, but the major advantage is I reduced 2 days. Initially the duration was 15, now I reduced into 13. So by reducing the duration also, I could decrease the total cost. That is what we will be doing it in crashing. So I am optimizing the time duration such that my total cost is reaching its minimum value. I cannot decrease further. 57 is the minimum value. Corresponding to 57, my project duration, my optimum project duration is 13. By crashing 2 days, okay, by crashing 2 days, I could able to reduce the total cost by this much amount, and I could able to optimize the time period, and that optimum time period of completion of project is 13. Very, very good question, but obviously this much big question possibility in GATE exam is tough. They can ask any part. Okay, now let us discuss some gate questions regarding crashing. What are all the gate questions which is asked? Okay, that we will discuss now. Okay.